very beautiful idea which is called this Euclid's algorithm. So Euclid's algorithm is basically used to find the HCF of two numbers, and of course with the help of HCF we can also find the LCM of two numbers. Not only two numbers, maybe more than two numbers, we can find HCF by using this very beautiful method. So it was actually done by Euclid. You know who is Euclid? Euclid is a very legendary mathematician. So he discovered this very beautiful idea to find out HCF of two numbers by a normal division method. So let's see, and with some example. So first of all, let's see an example by a very normal numbers. Let's see 6 and let's say 8. So what is their HCF? So first is a very small number. We just test to how we can really solidify the position and try to find out by the way of Euclid's algorithm. So first is this. So HCF of 6 and 8. Clearly by looking at these two numbers, we see 6 means 2 into 3 and 8 means 2 into 2 into 2. So of course their HCF should be 2. But we can use this Euclid's algorithm or Euclid's long division method, which is very popularly known as long division method. And let's see how it happens. So there are two numbers 6 and 8. So we should divide the large number by the smaller number. So here the large number is 8, smaller number is 6. So we divide 8 by 6. So starting like this. So 6 1, of course 6, 2 is remainder. Now since there is 2 remainder in the second step of this long division or this algorithm, 2 becomes the divisor and this divisor becomes the diffident. So that is the most important thing in this algorithm. The divisor in a certain step becomes the remainder becomes the divisor, the remainder becomes the divisor and the divisor becomes the diffident. So we use this. So 6 here. So that is the second step. So that is step 1 or S1 and that is S2. That is step 2. So in step 2 the divisor in the first step becomes diffident in the second step and the remainder of the step 1 becomes the divisor of step 2. Now we can proceed. So this problem ends here at step 2. Now when the division ends, actually now see the divisor, look for the divisor. So that divisor is the HCF of these two numbers. So now see that in this division over here on step 2 the division ends there. So what is the divisor? Divisor is 2. This means the HCF should be that number. So that is the HCF. So got this? 2 is the HCF of 6 and 8. So we can clearly say that is 2. All right. So that is that was a very two small numbers. So we should see some big numbers over there. So let's see how it happens. So one of the main reason why we should use this is to get a perfect clean advantage towards the big numbers, because when there are big numbers you don't know by which number you can divide them, or you don't know the very good process of prime factorization, because finding prime numbers will be difficult. So when there are big numbers you don't need to apply prime factorization, just divide them and you get the result. So that is the advantage of this method. Not only that, but also today's AI and computer, they think problems like this Euclid's algorithm. So that is probably the smallest and probably the easiest algorithm, but it is hugely used. So now let's see some very big numbers. I really like big numbers. I mean, I really don't like small numbers, because small numbers you can really see and you can do it by prime factorization. So let's see some big numbers over there. So our first one is this. So HCF of 117 and 221. So that is a problem from a book. So here we should just apply the direct algorithm. So that is the big number, that is a small number. So we divide 221 by 117. Okay. Now we see that we cannot use 2 over here, because if I multiply that by 2 it becomes bigger than this. So we should apply 1. So of course there is 1, so 117. Now see the remainder. What is the remainder? 7 to 1 means 4, 1 carry, so that becomes 0, that becomes 1, so 104. That is the remainder, so it becomes divisor, and that divisor becomes dividend. That is step 2. Of course it should be divided by 1. Of course the quotient should be 1. 13. Okay, you see that is 13. Now see by which number you should divide over here. So there is 13 and there is 104. So if you multiply 13 by 9, it becomes 117. Now if I divide by 8, so that becomes actually 104. So I use this calculator. Of course you can use some rough word, very easy. So 8 3 what 8 3 24 4 818 and then 2 110. So that's it. So it ends in step 2, that is S1, that is S2, that is S3. So it takes only 3 steps to find out the remainder over there. And from these big numbers, these are actually 3-digit number, you can see that how difficult it is to do the prime factorization, because these two numbers are all odd and you cannot even find, because they are not divisible by 3, of course. So that's what it is. So that's the difficulty. So that is the 13. Okay, so their HCF should be 13. So when the actual division ends here, the divisor should be the result. 13 is the HCF of these two numbers. Also we can use some other large numbers to find. So in later videos I will explain that how we can use for 3 number, not 2 but 3. If there are 3 numbers, you can also use this. If there are 3 numbers, we can use it. So let's see another example to do it by 3 numbers, but here we should use a little bit small number. So that is also a problem from a book. I don't know the name of the book, so let's see some small number, but there should be 3 number. Okay, so let's see some 3 numbers. 3 number means, so let's see another is this 12 18 and 20. Okay, so there are 3 numbers you can see. So first take 2 smaller numbers, 12 and 18, so divide them. So 6. So 6 is the HCF of 12 and 18. So at first write that. Okay. So HCF of 12 and 13, 18 is 6. Now there is 20. So we should divide 20 by 6. That is the actually step 2. Step 2 I would say. Now 6 of course by 6 3 we can divide. The division ends here, so 2 is the ultimate result. So 2 is the HCF between these all three numbers. So that's how we can use this algorithm to find HCF of 3 numbers. Not only 3 numbers, maybe if there are more than 3 numbers, you can also use this method to find that. And that's how it is. If you really like the video, you can comment if you have any question or not. And if you have really if you have any your personal opinion about this method, you can also comment, because this is a very old method and it is hugely used, and computer thinks numbers in this way. Thanks for watching.